So first thing, you have yesterday's assignment out. We're going to make sure that we know how to find relative max and min. And we know that we've already talked about this one day, so we're just going to make sure we're good with it on a calculator. So number 25, it says find the relative max and min. So you'll go y equals, you'll type it into your calculator. And I'm going to always, for myself, draw a rough sketch on my paper so that I can know what I'm looking at here. It really helps. So if you graph number 25, go to y, everybody should be doing it, go to y equals, and type it in. So you'll type in, here we go, x cubed, x raised to the third, minus 7x squared, plus 10x, here we go. And then you hit graph. Now look, I can see my graph, so I drew a rough sketch on my thing. Now this is a max and this is a min, correct? We're gonna choose which one we're gonna find first. Let's find the max first. You'll hit the second trace, go to max, hit enter. Now it's saying left bound. I've got to scroll and be left of the max. So I'm left of it. Anywhere left will work. I hit enter. Right bound, scroll right, hit enter. Says, do you want me to guess? We hit enter again. So you get 0.884.6. So I'm going to write that down. Right here was 0.88, comma 4.6. Was that what it was? And then let's find our min now. So you'll do second trace again. Second trace, go to min. Hit enter. Left bound, scroll somewhere left of the min. I'm to the left of the min, I hit enter. Right bound, I'm going to scroll right of the min. Anywhere right will work. I hit enter again. It ends up in the right spot, so I've done it correctly. That's 3.7 negative 8.2. So over 3.7 comma negative 8.2. Okay, everybody understand that those turning points are not increasing or decreasing. So now we're going to talk about increasing and decreasing intervals as well, even though it doesn't ask that. So everybody look up here. We're talking x values where our function is increasing and decreasing. You always look at your function from left to right. So if I was looking at this from left to right, or if I hit this function, wouldn't I be walking uphill? So I'm coming in from negative infinity, and I'm increasing until we hit that x value, which is 0.88. Does everybody understand? So increasing from negative infinity up to 0.88. What's most missed on the test is people will do y values, but it's just x values where we're increasing. Now, aren't we also increasing from that x value to positive infinity when I also be walking uphill right here? So we're also increasing from 3.7 to positive infinity. Now look, we're decreasing from this x value to this x value. Isn't that the only place we're decreasing? So our decreasing interval is from 0.88 up to 3.7. It's x values where we're increasing and decreasing. So 0.88, we were decreasing up to 3.7. Questions on that? Yeah, I want you to practice that. Do you want to do one more? So looking at number 28, if you graph it, it looks like this. Now, isn't this just going to be only a min, no max? There's no max. So we'll do a second trace min. And if you do that on your calculator, you get, now I want to do it because I want to show you something to remind you of a few things. So we go x cleared out, that's x squared, and then it was minus 6x plus 9. I'm going to do second trace. It's not a max, so you got to choose min. Left bound, I'm going to scroll left. I hit enter. Right bound, I scroll right. And I want to show you what I get. It's kind of interesting. So we get 2.99. Isn't that practically 3? 3 comma, and then 2.9 e to the negative 12. Remember that means you're taking your decimal and moving it back 12 places. 0.000000000. Isn't that practically 0? So this is 3, 0. So let's do intervals where we're increasing and decreasing. We're coming in decreasing up from negative infinity up to 3. Does everybody see why? And then we were increasing from 3 to positive infinity. Okay, I'm going to give you a second. Like literally, I can only give you like 2 minutes to practice the other two. And then we've got to get to today's lesson. So practice the other two on the worksheet, and then we will call it good. Attention, here we go. So in this unit, we're basically just becoming really good at all polynomials. Everything to do with polynomials, solving polynomials, and behavior of polynomials, and so on. So this is everything we've learned so far. Oh yeah, and notice it's polynomials of any degree. Back in secondary math 2, you only dealt with quadratics for the most part, and then in this class you deal with all polynomials of any degree. So we've learned end behavior of polynomials. Even degree has some end behavior, up and up or down and down, right? Positive is up and up, negative is down and down. We're all good with that. Then we've learned that odd degree polynomials will have opposite end behavior. Positive will be down and up, and negative will be up and down, right? Then we've learned how to find max and mins of polynomials. We talked about intervals where a function is increasing and decreasing. We learned last time, when given the zeros, when given the solutions, how to work backwards to find a polynomial. What do you use? Subtract 2, subtract 3, subtract 4, write it as linear factors and multiply it out. And then we've been learning last time how to solve many higher degree polynomials, and we solve them by getting them down to linear or quadratic factors so that we can solve them. Really, from here on out, the rest of the unit, we're just going to be solving polynomials, and the goal is always the same. You either get it down to linear or quadratic factors. But just like with a quadratic, you know how we had to learn different ways to solve different types of quadratics? Yeah. That's what we're doing with polynomials. We're learning different ways to solve different types of polynomials that you're going to see. But the goal is always going to be the same. We need to get it down to linear or quadratic factors. Yeah. This is all just a review of what we've learned so far. So even the front of the worksheet, here we go. So it says, so today we're doing 2-4. We're going to be solving polynomials that are quadratic in form, and we'll talk about that in a second. We'll also be solving polynomials that are the sum and difference of two perfect cubes. We'll get to that in a minute. So once again, whenever we're solving a polynomial, we want to get it down to linear or quadratic factors so we can solve them easily. So each polynomial will be able to be put into linear or quadratic factors by a different method. So looking at this, isn't it quadratic? So we would factor it. What multiplies to be, this is number 5 on your worksheet, the front, what multiplies to be negative 27 and adds up to be negative 6. We should be pretty quick at this. What is it? Negative 9 times 3, correct? Can we quick factor it? Yeah. So this factors to be x minus 9 times x plus 3. Now, those are linear factors. We can set each of those equal to 0 and solve. So we have x minus 9 equals 0 and x plus 3 equals 0. Solve for x. Using algebra, we would add 9, correct? So we get x is equal to 9. We would subtract 3 from both sides. So we get x is equal to negative 3. We have 2 solutions. It was degree 2, so we should have 2 solutions. Does everybody feel good about that one? So looking at number 6, it is not quadratic. We have 3 terms, and isn't there a GCF? So that's how we would solve this one. We're going to factor out the greatest common factor, which is n. Left is n squared plus 17n plus 72. Now look, we have a linear factor and a quadratic. We always see the quadratic factors. What multiplies to be 72 and adds up to be 17. 8 times 9, you guys, right? We can quick factor this because our a value is 1. So that's going to factor to be, we have our n, and then this piece is going to factor to be n plus 8 and n plus 9. And now look, we went from a cubic down to 3 linear factors. We can set each of them equal to 0. So we have n equals 0, n plus 8 equals 0, n plus 9 equals 0. So we have n equals 0 as a solution. Subtract 8, we get n is equal to negative 8. And we get subtract 9, n is equal to negative 9. We have 1, 2, 3 solutions. It was degree 3, so we better have 3. So that's, we've been solving polynomials. So looking at this one, wouldn't we solve this one by, there's no GCF, but it's by grouping, correct? Okay, let's do it. So we factor out of v squared. Left is 2v plus 7. And common here is that negative 8.
Yeah.
So I would pull out negative 8, divide by negative 8 to both of those guys. So left is 2b plus 7. Okay, it did factor by grouping, so we can factor out 2b plus 7, and left is b squared minus 8. Now look, we factored it down to a linear and a quadratic. Now we can solve each of those by setting them equal to 0. So we have 2b plus 7 equals 0. So when we subtract 7, divide by 2. So b is equal to negative 7 halves. There's one of our solutions. This one, we have b squared minus 8 equals 0. We're going to solve the quadratic using the most appropriate method. That would be adding 8, square rooting it. Correct, guys? So this shouldn't be too fast for you at this point. We've been going over this so many times. So we'd have to do the algebra, though. A lot of people mess up and don't actually do algebra to get 8 over here, and they get it wrong. So we have b squared is equal to 8. We'll square root both sides of the equation. So we get b is equal to, can't we break that down? 4 times 2, 2 and 2. So we'll pull out a 2, square roots of 2. 2 square roots of 2. Oh, what did I forget? Plus or minus. We have 1, 2, 3 solutions, and our original polynomial was degree 3, so we've got all 3 of them. Okay, all feeling good? Okay, I don't want to spend more time going over those on front because the back page is going to be the new stuff. So let's just get right to it. You understand that stuff, that's great. So we're just going to be solving polynomials for the rest of the unit, but they're going to be by a different method just because you can't solve it by any of the methods we just learned in the other lessons. So everybody look at number 9. This is an example of solving a polynomial that's quadratic in form. Now here's why it's quadratic in form. So look at number 9. Do you see how we have x to the 4th minus 5x squared plus 4? Doesn't that look pretty similar to x squared minus 5x plus 4? And this is a quadratic. We know how to solve a quadratic. So notice something. This goes down in 2's. X to the 4th, and then x squared, and then x to the 0, correct? This is when you have quadratic in form. So we're going to make, it's called a u substitution. We're going to say, let x squared equal u. We're choosing that every time for x to the 4th, x squared, and if we have a constant, we're going to do a u substitution. So I'm saying, let x squared equal u. Now think about it, guys. Properties of exponents. X to the 4th, isn't that x squared squared? Raise a power to a power and you multiply. Okay, I'm going to rewrite x to the 4th as that. Then we have minus 5 times x squared. And then we have plus 4. Now look, we have an x squared and an x squared. We're rewriting, instead of an x squared, we're putting in u. Wherever there's an x squared, I'm replacing it with u. Does everybody see what I'm saying? So this is going to become u squared minus 5 times u plus 4. Now look at it. Isn't it quadratic? No? And now we know how to solve a quadratic. We solve a quadratic by factoring if possible. Does everybody see how I made the u substitution before I continue to solve it? Okay, so now we're going to say, okay, sweet, I'm solving that quadratic. Let's solve it by factoring, if possible. So it multiplies to be 4 and adds up to be a times c and adds up to be b, negative 5. 1 times 4, negative 1, negative 4, correct? Can we quick factor it? Yes. My a value is 1, so this is going to factor to be u minus 1 times u minus 4, correct? Yep. Now we will set each of those equal to 0 and solve. So we'll add 1, so u equals 1. But we're not going to circle that answer. Sorry, I'm going to erase that. We're not going to circle that answer yet. Okay, we get u equals 1, and we get u equals 4. Now that's u. Didn't we start with x's? Yeah. So we have to go back and say, okay, sweet, that's great, but we know x squared is equal to u. So isn't x squared equal to 1? And also x squared is equal to 4. So now it's just one last step to solve for x. What would we do to get x alone? Square root both sides of the equation. So what we get, x is equal to plus and minus 1. We'll square root this side and this side. Root cancels out with power. We get x is equal to plus and minus 2. We have 1, 2, 3, 4 solutions. wasn't it degree 4? Yep, so we've done it correctly. Pretty cool. Questions? Let's do another one. Number 10. So make sure you're really paying attention to like why you're doing this, because we would only ever use this method of U substitution if it went from 4 to 2 to 0. So degree 4 to 0, we can use it. If it's 4, 3, 0, we can't use it. Does everybody understand? Okay, so look at number 10. We have a quadratic in form. So we're going to say, let x squared equal u. Is everybody comfortable with that? So isn't this going to be u squared? Do I need to write that out again one more time, the x squared squared? Okay, so we're going to have u squared minus 12 times u plus 11 equals 0. Now we're going to solve the quadratic by factoring. Well, multiplies to be 11 and adds up to be negative 12. 1 times 11, aren't they both negatives? So this is quick factor because my a value is 1. If my a value was not 1, we wouldn't quick factor. We'd drop and break and go through the process. So we have u minus 1 times u minus 11, and now solve. So when we add 1 to both sides of the equation, I'm only going to skip, but you guys can't make errors if I do that, because a lot of people were my first hour. So we get u equals positive 1. We would add 11 to both sides of the equation. So we get u equals 11. We started with x's, so we can't take u's as our answers, but we know x squared is equal to u, so we have x squared is equal to 1. We have x squared is equal to 11, and then last step is solve for x. Square root both sides, correct? Root cancels out with power, so we get x is equal to plus and minus 1. Square root both sides. So we get x is equal to, square root of 11 doesn't simplify, so we have plus and minus the square root of 11. 1, 2, 3, 4 solutions, it was degree 4. If we have a negative under the square root, won't it be I? Okay. Questions? Do you want to do one more, or do you think you're good? Sure? You're sure? Yeah. You want to do 11? Let's see, if I would rather do 11. Okay, let's do 11. So it's quadratic in form, x squared, x fourth, x squared 16. We're going to say, let x squared equal u. So that's u squared minus 10u plus 16. And now we'll set each of those, now we'll solve by factoring. Well, multiplies to be 16 and adds up to be negative 10. Negative 2 times negative 8, yeah? Quick factoring once again, so we have u minus 2 times u minus 8. Solve for u. In each case, solve it correctly. We'll add 2. U is equal to 2. We'll add 8. U is equal to 8. So we have x squared is equal to 2, because x squared was u, and x squared is equal to 8. And now we'll solve for x. Square root it. Root cancels out with power. X is equal to plus and minus the square root of 2. There's 2 solutions. Square root both sides. So we get x is equal to plus and minus. Don't we know how to simplify that? 2 square roots of 2. So we have plus and minus 2 square roots of 2. Now if we ever got the same root, which those are different. This is 1 square root of 2, 2 square roots of 2. But let's say we got the same thing twice. That would be a multiplicity of 2, correct? Both of them? Yes. All right, any questions? You're feeling good? I'm going to let you practice. So what you're going to do is 9 through 16, and then check them with me. Do it on a separate sheet of paper. Number 27, for example. If I gave this to you on the test, and I said to you, find the solutions, we would say to ourselves, okay, we know finding the solutions, we can solve it. Every polynomial is different. Oh, this one's a quadratic in form, correct? So we would say, okay, we're going to do a u substitution. So we're going to say let x squared equal u. So won't this be 2 times u squared? Minus 26u minus 28 equals 0. There's an easy way to solve this. I want to be able to quick factor it if possible. So let's factor out a 2 first. Don't they all divide by 2? That would be the smart thing to do. Let's pull out a 2. So divide each term by 2. You got to write the 2 out there. So then left is u squared minus 13u minus 14, right? Now when we have this 2, there's no variable, it's 2, so we're not going to set that equal to 0. Look, 2 equals 0, that doesn't even make sense, right? 2 doesn't equal 0. So now to solve this piece, we can ignore 2 for a minute. We can just ignore it. So we're quick factoring it. What multiplies to be negative 14 and adds up to be negative 13. That's 1 times 14. Negative 14, right? Now we can quick factor it. We're ignoring 2. This is going to factor to be u minus 14 times u plus 1. And now we'll solve each of those. So when we get u equals 14 and u equals negative 1. And now we have x squared is equal to 14. Did I do something wrong? No, I didn't. And x squared is equal to negative 1. Now we'll square root both sides of the equation. So x is equal to plus and minus 7 times 2. We can't pull either out, correct? So we'll leave it as the square root of 14. And then we'll square root both sides over here. Isn't the square root of negative 1 I? So we get plus and minus I. We have 1, 2, 3, 4 solutions. It was degree 4. So remember that because 2 didn't have a variable with it, we could just ignore it. Because I want to factor our solutions. But if it had a variable with it, we would have 2, like let's say it was 2x, then we would have 2x equals 0. So then we would have 0 as well. But then that would have been degree 5. Does that make sense? Unless there was a variable, yes. Unless there was a variable, you can just ignore it for solving. Okay, good question. Okay, looking at number 31. Looking at it right now, do you guys see how it's not equal to 0? So your first step is to get it equal to 0. Now, a lot of people, this is what you're going to want to do, and you're going to not do it. You're going to refrain from it. You're going to want to bring x to the 5th over because that's only one thing to bring over. However, at all costs, I want to keep the leading term positive. So I'm going to bring these both over. So I'm going to subtract x cubed. I'm going to subtract 12x. Do you guys understand that, what I'm doing? Yeah. So let's write it in standard form. X to the 5th minus x cubed minus 12x equals 0 now. It's in standard form. So is this quadratic in form? No. But what should I do first anytime I'm solving anything? Pull out a greatest common factor. So my first thing is to pull out x. So then left would be x to the 4th minus x squared minus 12. Now we're going to set each of those equal to 0 and solve. So when we get x equals, this one does matter, right? Yeah. X equals 0 is a solution. But now we're saying, okay, how do we solve that? Well, it's quadratic in form, so it's u substitution. So ignore x equals 0 for a minute. We have u squared minus u minus 12. So we're looking for what multiplies to be negative 12 and adds up to be negative 1. Negative 4 times 3, correct? So this factors to be u minus 4 times u plus 3. Let's solve for u. So we get u equals 4, u equals negative 3. So we have x squared is equal to 4. We have x squared is equal to negative 3. And now we'll solve for x. Square root both sides of the equation. X is equal to plus and minus 2. Square root both sides of the equation. We get x is equal to I square roots of 3 plus and minus, right, everybody? We should be able to kind of see that pretty quick. So let's count how many solutions we have. 1, 2, 3, 4, 5. It was degree 5. We're golden. That was a little fast. Is everybody feeling okay though? Do you see like how it's just no different, but it's just applying everything we know? Yeah. Because we have an x in the beginning that we had to factor out, and now we set each of those equal to 0 and solve. Yes. Okay, sweet. Okay, last thing. Awesome. You guys are doing so good. So next thing is we're just going to learn, I'm going to teach you, the first thing I'm going to teach you, before I can teach you how to solve these, I'm going to have to teach you how to be able to factor them appropriately. So before this class, before this hour, if I said to you, solve this, you probably would have subtracted 64 and took the cube root. But then we would only have one solution, correct? So you'd be missing 2 solutions. And that's because until this moment, you didn't know that this actually factors down to have a linear and then quadratic piece. So to actually solve these correctly, you have to be able to factor them correctly. So everybody understand something. When solving a polynomial, that is the sum means addition, or difference means subtraction, of 2 perfect cubes. Now I have to give you some vocab. A perfect cube means you can take the cube root and it comes out a whole number. Did everybody hear that? Yep. So let's see. Is the cube root, let's take the cube root of x cubed. Isn't root cancel out power? Didn't that come out whole? Yes. What's the cube root of 64? Now, do you know how to type that into your calculator? Let's all learn. Ready to learn. Here we go. Everybody, you go like this. Math down to cube root. I type in 64. 4, but do you guys, but does everybody see how to type it in? That's what I'm getting at here. Okay. So we know that 64 is also a perfect cube. Does that make sense? Perfect cube means it comes out evenly. So everybody, do you see how we have a sum of 2 perfect cubes? We have a difference of 2 perfect cubes. Why is 8x cubed a perfect cube? What's the cube root of 8? What's the cube root of x cubed? X. And the cube root of 27 is 3. So we have the difference of 2 perfect cubes. So what you are going to do is you're going to, something like this factors to be this. Something like this factors to be this. So if you have the sum of 2 perfect cubes, it's going to factor to be this form. If you have the difference of 2 perfect cubes, it's going to factor to be this form. I'm going to teach you a little saying that helps me because I don't even have this memorized. I know other teachers will just say memorize that and plug it in. You have to memorize a process, but I'll give you a trick to help you kind of. So the first thing is I'm going to, okay, so just everybody pay attention to this so that you can understand the little trick I'm giving you to help you factor it. So if I take the cube root of the front thing like this would be considered front because it's the front term's perfect cube root. That's the front. Do you see how this is the back term? I take the cube root of that, that's called the back. So what it's going to do is you're going to put in, the trick doesn't start here, but you're going to put in the front thing and the back thing, and then this sign is always going to be the same as this sign. Does everybody see what I'm saying? Kind of. Then the saying goes, you do the front with the front, then the front with the back, then the back with the back. So I'll do that again. The front with the front, then the front with the back, then the back with the back. So what I mean is front with front. A times A is A squared, correct? Then the front with the back, that's A times B. Do you see how we have an A times B? Ignore the sign. I'll tell you this how the signs work in a minute. Then the back with the back. B times B is B squared. Does everybody understand? So then this is how the signs work. This sign is always going to be the same as the original sign. Does everybody understand? Then this sign is always going to be the exact opposite of that sign. So if this is positive, this is negative. This end sign is always positive. Okay, so that's how that works. Now, if you do that same trick with this, even though there's a negative here, you ignore the negative. The front thing would be A, the back thing would be B, and then we do A and B. This sign is the same as this sign. We do the front with the front. That's A times A, which is A squared. The front with the back, that's AB. The back with the back, which is B squared. Then you fill in your signs. This sign is the same as this sign. This sign's always opposite of this sign, and this sign's always positive. So this will come with practice. Now, everybody, that just factors it. Then you'll have a linear factor and a quadratic. You'll set each equal to 0 and solve. Okay, here we go. So number 2, you have to decide. If I say to you solve, is this 2 perfect cubes? Yes, look, let's take the cube root of x cubed. This is our front thing. You take the cube root of that. So the cube root of x cubed, we get x, correct? That's what I'm going to call front. Now you'll take the cube root of this thing, not including the sign. The sign has nothing to do with it. Take the cube root of 64 and we get 4. This is considered the back. So now we're just going to factor it. You put in your parentheses, you put in the front thing, you put in the back thing. Your song hasn't started yet. This sign is always the same as that sign. Here we go. Okay, now we're looking right up here. We're looking up here. You do the front with the front. So x times x is x squared. Then the front with the back. So x times 4 is 4x. Then the back with the back. 4 times 4, 16. And now we'll close our parentheses. Let's go through and figure out what our signs are. This sign is the same as that sign. The next sign is always opposite. And then this sign is always positive. Now look, we factored this down to a linear and a quadratic. We know how to solve each. Set each equal to 0 and solve. So we have x plus 4 equals 0. So when we get x equals negative 4. There's one of our solutions. Now I'm going to tell you, you should try to factor it, but I'm going to be honest with you. If you ever have two perfect cubes, this will never factor. You're going to have to use quadratic formula. So let's do it. Here we go. Brace yourselves. Pay attention, because I'm going to be honest, my first hour, they just nailed it. Everybody was doing quadratic formula correctly, and so it just went smooth. So let's go for it. X equals negative b, won't that be positive 4? Plus or minus the square root of b squared. So that'll be negative 4 squared minus 4 times a times c. And then it's all over 2 times a. So we would say x is equal to 4 plus or minus the square root. I can't stress it enough. We only type in that, not the square root part. What do you get? Tell me. Everybody calculate it. Negative 48. Did we all get it? Now we're at this point. Would it ever be appropriate to take 4 divided by 2? No, right? Never, because this is also divided by 2. This is always the point where we go off to the side and we simplify the negative 48. That's negative 1 times 48. 48 breaks down into 8 times 6. 6 breaks down into 3 times 2. 8 breaks down into 4 times 2. And 4 breaks down into 2 times 2, correct? Okay, pulling out groups of 2. We'll pull out a 2. We'll pull out a 2. And left is a 3. We'll pull out a I. So when we be pulling out 4 i's and then square roots of 3 is left. We should be able to see it that quickly. So we have x is equal to, so I'm going to write it right here. X is equal to 4 plus and minus 4i square roots of 3 all over 2. Then you would say, do all three things divide by 2? Yes. Oops, that color, different color. So this becomes a 1, a 2, and a 2. So my final answers are x is equal to negative 4 and x is equal to 2 plus or minus 2i square roots of 3. Anything divided by 1 is just itself. We have 1, 2, 3 solutions. Wasn't it degree 3? Yes. Questions on that? Yeah, we're going to do another one. So you got to be able to do the quadratic formula correctly. That's why I'm so glad we spent a whole extra time making sure. Can you imagine learning this on the 3rd day, 4th day of school? That would have been a nightmare with where we were with the quadratic formula and stuff. Here we go. Let's do number 11. Here we go. So we would say to ourselves, we're solving the polynomial. How should I solve it? Well, this looks like it's 2 perfect cubes. The difference of 2 perfect cubes. But let's see. Take the cube root of the front thing, the cube root of 8x cubed. Take the cube root of the back thing, 27. You do not take the negative with it. Does everybody understand? Okay, what's the cube root of 8? It's 2. What's the cube root of x cubed? X. The cube root of 27 is 3. Okay, now we can do our little parenthesis thing. If this is a minus sign, then right here's a minus sign. Now, the minus signs won't affect this next part. Front with the front, this is where a lot of people mess it up. 2x times 2x. That's 4x squared, guys. 4x squared. Then the front with the back. Do not multiply the sign in. 2x times 3. 6x. Are we all following? Then the back with the back. 3 times 3 is 9. Now we can put in our signs. If that's minus, this is opposite, positive, this is always positive. Now that's simply factored it. Now we have a linear and a quadratic. We know how to solve those. So we have 2x minus 3 equals 0. We'll add 3. So we have 2x equals 3, divide by 2. So x is equal to 3/2. There's one of our solutions. This one's going to be imaginary. You're going to have to use the quadratic formula. So let's go for it. So we have x equals negative 6, negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a, so you're going to only calculate this part. So we're going to have x is equal to -6 plus or minus, calculate it. You should all practice, because if you're not getting the right thing, it's because you're not typing it in right. -108. That is correct. So then we're go off to the side. We say I can simplify -108. 108, 2 times 54. 54 breaks down into 8 times 6. 8 breaks down into, right, 4 times 2, 2 and 2. And then 6 breaks down into 2 and 3. Pulling out groups of 2 and pulling out an I, correct? So we're going to have a 2 and a 2. Left is a 3 and a 2, correct? Okay, so we have x is equal to -6 plus or minus. We're pulling out 4i square roots of 6. Which problem is this again? Okay, perfect. And that's all over 8. Now don't all, I messed up somewhere. It's not, what, 9 times 6. That's why. Okay. Oh, that 2 was fine though, right? Okay, so this was 2, this was 9 times 6, this was 3 times 3, wait, right? Yeah. Okay, so 6 is 2 times 3. Okay, so we'll pull out a 3, we'll pull out a 2, and left is a 3. There we go. Is anybody lost? So 2 times 3 is 6. We're pulling out an I, and then we're left with a square root of 3. There we go. So now all 3 things divide by 2. So this becomes a 3, a 3, and a 4. Yep, so we get x is equal to -3 plus or minus 3i square roots of 3 all over 4. We have 1, 2, 3 solutions. It was degree 3. I'm going to just say one last thing, then I'm going to let you practice pretty much the rest of the time. Number 3, is 2 a perfect cube? No. So, but it kind of looks like it should be the sum of 2 perfect cubes, right? Well, it probably is. The first thing you should do is factor out the greatest common factor. What's in common to 2? So we'll factor out a 2, divide each term by 2, and left is x cubed plus 27. Now we can continue to solve, because isn't this a perfect cube? We can ignore 2 because there's no variable. Does that make sense? So now this is going to be x. The front thing is x. The back thing is 3. This will factor to be x plus 3. Do you guys see what I'm doing here? Front with the front is x squared. Front with the back is 3x. Back with the back is 9. If this sign's positive, this sign's negative, this sign's positive, we'll get x is equal to -3. And then we'll quadratic formula this. The 2's not going to affect the answers because the 2 didn't have a variable. Is everybody good? Yeah. Do you want me to just give you the answer and then you can check it with yours to see if you get it? Or what do you want? Number 3, do you want the solution and then you can go back and see if you can do it at a later time? Yeah. So we have x is equal to, we would do the quadratic formula. You should get 3 plus or minus 3i square roots of 3 all over 2. This was missed by like most of my honor students, and it wasn't any harder than this on the test. Literally, like I think it was like problem number 2 on the test, and they missed it. But you just got to know what you're doing with these, and then you should be good. And you got to solve with the quadratic formula correctly. Okay, so what I'm going to have you do is do problems 1 through 8. Trick with me. Please be careful with the quadratic formula. It went so smooth first hour. So we should be factoring out an x, and left is x cubed minus 1, correct? Now set each of those equal to 0. So we have x equals 0, and then we don't know how to, we do know how to solve this, right? Then we have to factor it again using our little front and back thing. So this is, the front thing is x, the back thing is 1. We're going to have x minus 1, then front with the front would be x times x is x squared. Does everybody see what I'm doing with this? Front with the back is 1x, And this sign is opposite of this sign, then the back of the back is 1. This sign's always positive. So we have x equals 0 from that x. We have x equals 1 from that factor, and then we've got to do quadratic formula. So we would go through it. You guys are good with the quadratic formula, so I'm going to give you that answer. But does everybody see how we would do that? Yeah. Okay? So that's testing a lot of knowledge there. So you would get x is equal to 25. And you could check this later if you had extra time. -1 plus or minus I square roots of 3 all over 2. So we would go through the quadratic formula. Check how many solutions you have. 1, 2, 3, 4, and it was degree 4. So we're good. Okay, another one. Number 30, if I said to you, solve this one on the test, and you just took the 4th root, you'd get it wrong. How many solutions should we have? 4. So you would say to yourself, okay, first of all, I need it equal to 0. So we have x to the 4th minus 25 equals 0. Now this is actually quadratic in form, because if we say let x squared be u, then isn't this u squared minus 25? Now let's solve for u. So what do we add 20? We could solve by factoring, or we could add 25 square root it. Let's just do that. Is everybody okay with that? So we have u squared is equal to 25. We square root both sides. So we get u is equal to plus and minus 5. So we know x squared is equal to 5. We know x squared is equal to -5. We would square root both sides of the equation. So x is equal to plus and minus the square root of 5. There's 2 solutions. We would square root both sides over here. We get x is equal to I square roots of 5 plus and minus. We have 1, 2, 3, 4 solutions. It was degree 4. Did everybody see how that one was a u substitution? Okay, sweet. That's all I was going to get at today. Okay, so how about, I'm just going to let you at this point not finish the worksheet, but finish up through 16. And then whatever we did in class on 25 through 32, that's what's going to be required. Because we don't have time to do the other, like the... Don't cross them out. We do need to talk about those, but next time, once again, we keep in this never-ending spiral of pushing it to next time, but I don't want to overwhelm you. So that's what I'm going to do. It's just not have you cross them out, but up through 16 be done, and then maybe let's have it up through 32 as well. Just on the today we're just focusing on the back. So on the front we're good. Just whatever we did is good. I just don't want to overwhelm you. So you're finishing up through 1 through 16 on the back, and then I want you to try 25 through 32 on the back, and then the others we'll get back to next time.